So, Umut, as I was explaining to you, the first couple of minutes, I will do a quick intro in English, in Portuguese,
Yep.
for my local audience. So, and then probably after this intro, I will switch to English and we proceed of course, your presentation and all the discussion questions, all in English. Then in the last probably 3 or 4 minutes, I will give you some short message in Portuguese as well, just for you to understand the dynamics. Is it okay for you?
Sure.
All right. And so basically we are almost on time to start. Just for your reference, we already have, how many guys we have, Thiago?
My friends told me, are we live now? Can they hear us?
Yes, we already are live. Okay, so if you don't mind, Umut, I will start with the quick intro, okay?
Okay.
Boa tarde, pessoal, ligado no canal do YouTube da EA, Associação Brasileira de Engenharia Automotiva. Para os que ainda não me conhecem, meu nome é Anderson Suzuki, eu sou responsável pela área de comunicação e eventos dessa associação. O tema da live de hoje é Aplicações Automotivas da Inteligência Artificial e Machine Learning, e contaremos com um convidado internacional para debater esse assunto com a gente. Mas antes, para você que ainda não se inscreveu no nosso canal, inscreva-se e ative as notificações. Good evening to our international audience. It's a pleasure to have you joining our first webinar in English and support today's discussion. By the way, if you want to be updated about future live transmissions, please subscribe to AEA, Brazilian Association of Automotive Engineering, YouTube channel, and press the notification button. Guys, I will start with a quick intro in Portuguese of around 5 minutes and then switch the discussion to English. So please hold on for a moment. Hoje estamos na nossa 8ª transmissão da série Live AEA Digital, né, que tem como objetivo fornecer o conteúdo técnico, atual e relevante do setor. A dinâmica que estão participando pela primeira vez, né, por sinal, sejam bem-vindos, né, welcome to the international audience as well. A dinâmica é a gente convidar profissionais do setor de mobilidade, do ecossistema de mobilidade, e propiciar uma discussão entre os nossos convidados, né, e o público sobre assuntos relevantes do setor. O nosso compromisso com vocês é oferecer essas lives semanalmente numa programação que a gente atualiza nas nossas mídias sociais. E falando da próxima live, que por sinal é um assunto que eu particularmente gosto muito, adianto que o tema será conectividade com a introdução do 5G. Fiquem ligados que darei informações mais detalhadas durante a transmissão. Mas enfatizo sempre, né, que a melhor maneira de estar atualizado sobre as lives AEA Digital é se inscrevendo no canal e clicando no sino de notificação. E aproveitem e deixem já o seu like. Já adiantando, gostaria de pedir para prepararem aí suas perguntas para o convidado de hoje e façam através do chat do nosso canal. E para iniciar a live propriamente dita, né, sempre começo agradecendo ao nosso convidado, ilustre convidado de hoje, que me ajudará a debater o tema Artificial Intelligence and Machine Learning Applications in Automotive. Pessoal, de agora em diante, né, como eu comentei, falo em inglês para inserir o nosso convidado e a audiência de fora do país nesse debate. So, switching to English, let me start with a remark for our international audience. Please be ready to make your questions or comments and do it through AEA YouTube chat, okay? Well, merhaba, guys. Did I pronounce well?
I think it was very good. It was
Okay.
very good for our Turkish audience.
Thank you. You are very kind. Anyways, let me introduce Dr. Umut Genc. May I call you Umut?
Yes, please. Thank you.
Okay, thank you. He has a Bachelor of Science degree in Electrical Electronics Engineering from METU in Ankara, Turkey. That's the capital of Turkey.
Yep.
And a Master of Science in Advanced Control from UMIST in Manchester, UK, and a PhD from Cambridge University in UK as well, in the area of engine electronics, controls, and software. Umut has 20 years of experience in automotive industry and powertrain engineering from working in several countries such as the UK, Austria, and Turkey. Umut worked for leading automotive technology and engineering companies like D-Space and IAV, and he was the managing director of AVL Turkey R&D Center before co-founding Eatron Technology in 2010, a couple of years ago. Eatron provides intelligent software products to automotive industry for electric and autonomous mobility. But before you start, I want to mention here, Umut, about one curiosity from you. That basically he has been fascinated by science from a young age, I would say pretty young. At the age of 7, he dreamed of being an astronaut, but very quickly realized that this was not possible for a boy from Turkey. Since then, he decided to stick to engineering professionally and science fiction on his spare time. As a child, read all Jules Verne and Asimov writings. One of his all-time favorite movie is The Matrix. It's one of my favorite as well. So we have this in common, which he has watched at least more than 10 times. So in terms of watching, you watch more times than me. You want me. Some of his favorite books are Forever War, Hyperion, and Brave New World, and as a comic, Attack on Titan series from Japan. Okay, so yes, it's from a good country. From your curiosity, Umut, I was wondering, what was the main reason to give your dream to be an astronaut up?
Should I start, Anderson? Or
yes, so just, so now I want to call you to help me discuss about AI and machine learning with our audience. So, Umut, be free to share with us your initial thoughts about the team. Please, go ahead.
Okay. No, Anderson, thank you very much. Well, first of all, I want to thank you, and I want to thank AEA, for this opportunity. I think it's quite special to be here, connected with the colleagues, engineers in Brazil, but around the world, in Europe, in Asia, in Turkey. So I quite feel very special. So really, thank you for this opportunity. I hope everybody will enjoy this. So let me share my screen, but while doing that, I will also tell you why I learned very quickly I cannot be an astronaut. So basically, I think even at a young age, I was very result-oriented. So I like to put targets, objectives, and achieve them. And I saw that it would be very difficult for a young boy coming out of Istanbul, to go to US and then go through all this selection and then go to NASA and then go to space. So I said, this will most likely will fail. And as I will tell you, I don't like to fail usually. So I said, well, let's stick something, easier to achieve and become a good engineer.
That's a good reason.
Yeah, that's a good reason. And then I do science fiction in my private time to enjoy, stories about being in space and going around the galaxies and all that. But okay, so let me also take this away. Yes. Just a second. So now, well, hello everyone, and so Umut Genc. I'm a co-founder and CEO of Eatron Technologies. I mean, today I'll talk about AI, machine learning, specifically what kind of machine learning we do in Eatron. So this will be really focusing on AI methodologies and techniques, what we do. So I'm not here to do marketing about Eatron, but of course you will see a lot of Eatron logos in our slides. But it's the format. Only one slide about what we are, because I think in front of this international audience, you don't know what we are really doing. So we are a startup based in the UK. We are really focusing on intelligent software. That means AI-powered software for electric and autonomous mobility, but specifically for battery management system and level 2+ ADAS. This is our mission. We really want to take AI into mass production. We are based in Warwick in England. Warwick is very close to some big OEMs, automotive OEMs. But we are an international startup, so we also have a team in Istanbul. And we are all coming out of automotive. So that's another reason why I really like this opportunity to talk to the automotive engineers. So our life is really, you know, last 20 years we've just been doing automotive. So let's now focus on AI. And I want to really start with what we mean by AI at the very first level. Sorry. Because AI is a very, very big word, right? Artificial intelligence, and different people understand this in a different way. You can have a very heated discussion around philosophy, science fiction, you know, what is possible or not. So when you ask me about AI, well, first thing that comes to my mind is, you know, very intelligent robots, like it was in the Asimov books, you know, I used to read when I was young. The other one is, again, very, very powerful AI, like controlling the spaceships, like in the movie in Space Odyssey, right? And this HAL 9000 was a bad one, and it could even kill the people to achieve its objectives. But this is not really the AI we are talking in engineering. So that's the popular AI, the hot one. But actually the real AI, and the AI I'm going to talk about today, is machine learning. So when I say AI, it means machine learning, right? So let's agree on this. And I will use AI a lot because it's the buzzword, it's also the short. But really I'm talking about machine learning, how to use data to train some software to do some specific tasks. And also next to machine learning, the big stuff I'm going to talk about, decision making. So these are the things I will talk about. And we all, I think, watched it and read it and saw it on the news and media, the rise of AI applications, right? So in the last 10, 15 years, there has been a lot of applications. For example, the computer vision, the perception, you know, object detection has improved a lot, but also natural language processing, you know, the translations, automated reply to emails, and any kind of speech to text translation. These are all has increased a lot around this latest AI applications, but as well as decision making, autonomous driving, but also in financial applications. So why all this happening? I think one of the biggest reasons is the improvements in the computation. So electronics really has improved immensely. We have now special chips, GPUs, so we can really train very, very complex neural networks to achieve some good results. Of course, the other one is availability of good data. So if you go more specifically, what kind of applications we do in machine learning? Well, number one is task automation. So we can automate any kind of task. So we can really train neural networks to do a lot of automation in that one. But we can also do failure detection. So end-of-line testing could be very interesting. And so these are, and also as discussed, you know, all this translating stuff, even developing digital assistants. But the other one is maybe not as popular as this task automation part, is making the good strategies. And we saw that lately, that Google DeepMind beating, you know, any kind of champion in chess, in Go. If you like computer games, and me and my son, we love StarCraft, but then this Google DeepMind can also beat you in StarCraft. So also this finding the optimal strategy very, very efficiently with the latest machine learning methods. So what are the main methods we use, the techniques? I mean, the most popular one and the one that we use a lot is called supervised learning to train our neural networks. And basically we have a training data, and we use this training data to teach the network some task or objects, and then we do the validation. And once we are happy with the training and validation, then we can use our intelligent software to do the automation or the application that we are targeting. So this is the most popular one, but there are also other techniques like unsupervised learning or semi-supervised learning. In that one, you don't have the labeled data. The data, I mean, you have data, but you don't have the classification. So really, you want the software to learn all this relationship between the data and then do the learning. So that's much more tricky, and it's an open area. And on the right-hand side is this decision-making one. The methodology is called reinforcement learning, and you really teach a software how to maximize a reward function by taking some actions. And this is really, really powerful, and I'll show you more examples here. Another very, very important aspect if we are dealing with AI is the safety. And I'm quite sure this will come up during our discussion. So, I mean, if you are using machine learning in a laptop or in a mobile app, safety isn't that important. But if you are using AI to control the steering, acceleration, the brake, driving the car, or in aerospace, then safety is paramount, because if anything goes wrong, and we know that sometimes these AI functionalities could come up with funny stuff. We know it from our apps, from translation. You can really get them to do some funny things by changing or playing with data. So this is not a big deal if it is on your phone. Maybe you just get a bit upset or you just laugh. But if something funny happens because of your AI software while driving the car, this can create a lot of harmful events. So this is not acceptable. So when we are dealing with automotive, it's all about safe AI. And for that, you need to have some special methodologies. And we also have one in Eatron, and we know that others also have it. But really the key point here, in automotive, if it is safety critical, safety is number one. So we have to be very, very careful that when we do machine learning in automotive, it has to be safe. So now I'll start going into more details. And the first two examples I will give you around the battery management system. So this is an automotive audience, so most of you know the battery management system. So it's the brain of the battery pack. So basically, the BMS controls the battery in the electric vehicle or hybrid vehicle. So it controls everything. So it controls the performance, the energy, the balancing, the safety, and the thermal. So it's very important. So what we do in certain functionalities in the battery management system, we use some machine learning techniques. And the first application we do is how to use AI to improve the diagnosis of the failures or the faulty cells in the battery pack. So we all know that the batteries are quite sensitive, so things go wrong. So the typical the diagnosis in a BMS, when you get a fault signal, then usually you already got significant problems in the battery pack. So either you are losing the performance, if you are a bit more unlucky, maybe then you are stuck on the road. If you are really, really unlucky, maybe there's a fire. But we also know that actually, by checking the right signals in the right way, we can detect problems before seeing any performance degradation of the battery pack. So it's possible. And then the question is, can we use some machine learning techniques to train an intelligent software that could detect the problems before anything can be felt by the driver or the passengers in the car? And for that, so this is our first AI application. So this is kind of the high-level architecture of our AI-powered diagnosis. So the first block is our signal preprocessing and analytics part. So this is really, we measure all the signals. So all the voltages, temperatures, and the current goes in here. And then in this part, you have to do really some careful measurement window, averaging, and the really processing of the right signals for the right duration. And this is kind of the expertise coming in, because this is also what you do as a human expert. And then once we have that, then we feed all this processed signals into our neural network here. And then we can train our recurrent to give us the fault status of each cell and also the failure level. So once we achieve that, then it goes to our more traditional diagnostics. So this is very powerful. We got patents also going forward in that area. But this really can save a lot of headache for the manufacturers as well as the drivers, and also good for safety. So this is our first application. So the next one is again about the battery management and the BMS. And this is about the characterization of the cells and also calibration of the BMS functionality. So usually when we are going for a serial production, and we have the battery pack, the BMS needs to be calibrated and all the data has to be collected. And that's a very long and time-consuming process. So it could be up to 6 months of testing in the laboratory. So this is expensive. And of course, you need to have the right experts. And you have to be very careful again, because there is serious danger, right? So the question was, again, can I use some intelligent software to reduce this time? Make it less expensive and quicker. And what is this? And I think some of you have done that before. This is really called design of experiments. And we did a lot of design of experiments in the past, not just for the batteries, but also engines, improving the fuel economy, reducing emissions and all that. So the question is really, what can we use on this latest machine learning technique to come up with the optimum DOE, or the input profile, for the testing of our battery and the cells? And the methodology here, again, I will reintroduce, is the reinforcement learning. And let me tell you slightly more here. So the intelligent agent is on the left here, right? And actually we use a neural network here to find the optimum policy. On the right-hand side is our environment or system. So actually for this specific case, this is our battery pack. And our software can take some action on the battery pack, but here actually this is the input signal. Yeah, the voltage signal we are giving. And of course, we got a reward function that we want to optimize. This is our optimum DOE. And then every time we give an input to our system, we look at the state, but also we look at how the reward is changing. And then we run an optimization here. And this is, of course, a very nonlinear optimization. So it's very good that we can use the latest neural networks to capture this optimum policy. So this is the maths. You can read it. It's very, very powerful. And you will see that I will use this methodology now for also autonomous driving later on. So in the case of the battery, then we have our battery pack, we have our intelligent agent, we get the data, and then we keep changing the input. And in the intelligent part, our deep reinforcement learning is running. When we do that in the right way, what you see actually is we get really, really good results, because we worked on that. So normally, when we do a set of characterization, this set of experiments at a fixed temperature, this could be up to 1,000 hours. So it's a very long process, as discussed. But when we use our deep RL-based software, the optimum design of experiments, we can reduce this duration more than 90%. So actually, it will be less than 100 hours. Of course, this is a very, very big step. And this shows, again, a very powerful way of applying machine learning for the right problem in automotive. So get better characterization in a faster time with less cost. So this was our second example. So the next one now, let's move to even more popular topic, autonomous driving. So in Eatron, we focus on semi-autonomous driving, so level 2+. And in the level 2+, we have the main adaptive cruise and lane-centric control functions, as well as the lane change. We have a demo car that we are testing all the time in traffic. But actually, let me go to our video. So I hope everybody can see one of our demo videos. So this is one of our demo cars running on the highway. So what we got? So we got the full control of the steering. So this is centering the lane. We have adaptive cruise control. So you will see that better when there are some cars in front of us. But also now we implemented our automated lane change. And this happens when you have the driver initiation. So when the driver signals it, the car automatically changes the lane. So this is a highway pilot level 2 environment. So what are we doing next on this? We like to fully automated the lane change, as well as further improve the adaptive cruise control. For example, here now the ACC is kicking in and keeps the right distance between the car ahead, well, in this case it's a truck, and yours. So let's go to some AI applications here. Application 3, but the first one for ADAS is actually how to improve our ACC algorithm using the machine learning. So for our adaptive cruise control, we are using a model predictive control, which is kind of state of the art. It's very, very powerful. But one thing we realize, when you have ACC, there could be different scenarios. The easiest one is you are just nicely following, so the blue car is our car and nicely following the car ahead of you, right? So you can optimize your MPC-based ACC for that scenario. But there could be another scenario, which is the cutout. So this red car could suddenly change lane, and suddenly you have another car in front of you, right? So actually for that, you can have a different MPC weights to get better performance. But then there could be cut-in. And this cut-in and cut-out, I'm sure, happens a lot in Brazil, right? People are more energetic and more active on the roads, on the highways. We also know that from Turkey, Istanbul. But there could be even reverse cut-in. So there are a lot of different scenarios. And what we did in this application, we said, why don't we use deep reinforcement learning to optimize the weights of the MPC while we are driving the car. And actually we showed that in simulation that you can get much better driving feeling, safer performance if you use deep RL optimized ACC weights in the ADAS application. And we published this last year in Paris in June in the Intelligent Vehicle Symposium. So that was one application. And really now idea is to take this into the production one. So this is running in the demo car, and then next really can we use this in production cars. This is real target for us. Now the last application for today is lane change. So I can do lane change by rule-based, if then else, fine. And we know that some companies, they have that rule-based. But then, can I improve this lane change performance? Can I make it, more human-like and also better and safer using deep reinforcement learning? And actually, again, we showed that on simulation, and we keep running on our simulation. And very soon, well, the team is promising probably in July we can show that in traffic in our demo car that we can do better lane change using deep RL agent than the rule-based. And this was again published last year in New Zealand IEEE. But I'll show you now further extension of this. This is not published yet. So you are the first ones, I think, seeing that. Hopefully we can go. I don't know if we can go to Las Vegas, but the paper is accepted. So really now next one is use that machine learning, deep RL based machine learning to predict the trajectories of all the cars around you, right? Because it's very important if you have a good estimation of what the cars around you will do, and then you decide about lane change. And we really use some state-of-the-art here. So there is a field of neural network, generative adversarial network based. So we can create scenarios using these GAN networks. And again, show that this intelligent agent makes even better decision for lane change in a busy traffic. So the last one, simulation is very important for training your machine learning algorithms. Of course, we use a lot of simulation. Let me share with you this one simulation that we developed. And turn off this music. So here, actually, this is where we train our neural networks, these deep RL algorithms for lane change, as well as optimizing the ACC weights. So if you want to do AI again, simulation is so critical. So before really doing the vehicle testing, you have to have a lot of simulation and make sure that you got enough maturity before you go to the road testing. So with that, Anderson, thank you very much. So yes, I'd like to thank you, and I will stop presenting so that we can continue a nice discussion together.
All right. Thank you very much, Umut, for your very clear presentation. So, and now let's move to the debate with our public. Before we start our Q&A session, I would like to ask our audience to prepare questions for our guest. Both English and Portuguese are welcomed. And he told me, I will tell a story, he told me that he's anxious to reply all of them, all of your questions. So please don't be shy. Anyways, to heat up the engines, I would like to start with some data from, I would like to share with you, Umut, from a 2008 report from by the Capgemini Research Institute called Accelerating Automotives AI Transformation: How Driving AI Enterprise-Wide Can Turbocharge Organizational Value. On this survey, they surveyed 500 executives from large automotive organizations in 8 countries and interviewed a number of industry experts and entrepreneurs to understand the progress in deploying AI at scale can be accelerated. So although AI offers a vast implication for engineering, production, customer experience, supply chain, and mobility service, progress in AI-driven transformation has been sluggish and uneven due to persisting roadblocks. Just share some numbers. The numbers of automotive companies deploying AI at scale has grown from 7% in 2017 to 10% in 2018. So not so big growth, with OEMs generally making better progress than suppliers. Talking about regionally, geographically wise, the US, where 25% of companies implement AI at scale, is leading the way in terms of progress, followed by the UK, where you live, with 14%, and Germany with 12%. So in pronounced growth, China, always China, is making huge strides, having nearly double its share of scaled AI implementations from 5 to 9, almost 10, so almost doubling.
Yep.
So with all this data, my question is on this direction. From this slow pace growth in 2018, so roughly 1 year ago, what are the roadblocks that are holding the growth of AI implementation in automotive? And a second one, what are the alternatives to mitigate such barriers?
Okay. No, I think very good and relevant question. Thank you for that. Well, the biggest roadblock, in my opinion, in automotive, and I think slightly touch base during the discussion, my presentation, is when in automotive, the safety standards are so very critical for us, right? And we need to do the proper validation and then certification of the certain products, certain systems, and then the whole vehicle. And of course, with AI, it is very difficult to do the complete validation and then certification of the system, of the software, and then the whole vehicle. But of course, this also changes from region to region, right? So different markets, different countries, regions have different certification requirements and regulations. And I think some of the differences you see are kind of because of this the difference in the regions. And in terms of regulation and certification, we know that, for example, Germany is very strict. And I think your number also confirms that in Germany, the use of AI is less than some other regions. So the fast introduction of AI currently requires some risk-taking. And of course, in automotive, that's difficult to take risk. Maybe in certain regions, they can take slightly more risk. But definitely the safety is one of the big problems. The proper tools for the verification validation is not easy. And of course, we also need a lot of data. And sometimes data is not available. And I show that we have to use a lot of simulation. So we got some good simulation tools, but not in every scenario. And so there are several problems, but it's all coming around how do we fully validate, verify, certify, and show the safety of the AI use case. So that's I think is the real problem. And so how can we go around this? I think we need to spend, we need more expertise around these latest machine learning methods. We need to find ways to validate this machine learning with maybe further machine learning. So we think more and more if an AI algorithm can validate another AI algorithm, right? And can we integrate our simulation tools, some master AI that can, validating, checking the other AIs running in the simulation. So we need more simulation, we need more data, but also we need more regulation from the lawmakers. So they need to also make it clear what is needed to be done. What is the certification process for level 2 or level 2 plus ADAS? So these are also, so a lot of factors needs to come together to accelerate the use of AI in automotive.
Thank you, Umut. And by the way, you mentioned about the role of the question related to improvement of the regulations, right, with safety as the main driver. I'm wondering if the skills or the knowledge of the government bodies in the countries, if they are ready, if they know about AI and machine learning, and if they, how can I say, if they can really support the industry on the regards of AV. I'm wondering about the skills, if they are ready to make these new laws related to AV.
Well, in reality, I mean, of course, I don't know the whole world and everywhere, but my personal understanding, of course, skills are not there. There is a lot of hype and buzz around AI, as I show you, and that's why one reason I opened with my sci-fi books, right? So some people think this AI is really like a super duper intelligence, and so people read a lot of popular magazines and got a feeling of AI that is much more capable than reality. So even within our community, even with some engineers, although people understand AI machine learning, when it comes to the real maths, what is really possible and how do we really train these things, understanding is limited. And that's why I believe that it creates a lot of confusion on the bureaucrats, on the civil servants. How can they really regulate this kind of intelligent software? Because definition of this intelligence isn't well defined. And if you are not careful, you really start going into this science fiction area of intelligence, and that's maybe even confusing them more. So the short answer is, unfortunately, no, we don't have the right experts in place. And I think that the real expert who understand the maths behind it, because at the end this is all maths, right? You solve an algorithm and optimization, and that is really lacking in some certain key decision-making policy units.
Yeah, because I think that it's a question for me. It's what is the priority, right? Because what is the priority for the industry? What are the priorities for the government? So, and this in some way it needs to match, right? In order to have the right technological solution and with the right regulation, considering, as you mentioned, the main driver, which is safety. Right?
Yes.
Okay. We are starting to receive some questions from our audience. One from Emerson. Basically, Umut, he's asking, is there any kind of simulation with person in the traffic simulation with real people. Are you working on it?
Simulation with real people.
Yes, exactly. Not
okay.
Computing simulation, actual simulation.
So I understand this like people sitting and there's like a big simulator, like a flight simulator or like a driver simulator. So
no, I think that, for instance, you have, for example, autonomous vehicle, and this car is driving autonomously, and one guy crossed the street or a child, this kind of thing. So real life simulation with a vehicle. I think that's the direction he asked.
No, I mean real life. Okay. This because simulation means it's kind of a virtual environment. So I know that some people, I'm not sure if I understood the question fully, but I'll tell you how much I understand, and I'll tell you the really far extreme, this really, in my opinion, crazy idea of simulation. So you have the real car, right? So yes. You're on the test track in the real car, you are driving the car, but then all the other cars around you don't see, but virtually there are other cars and traffic around you. And then your car sees it, and then you can check in this virtual, although it's the real car, real person in the car, but all the other cars, all the signals coming, telling you that there are other cars around. So you can create a lot of this kind of augmented reality environment that you can have other simulated cars, virtual cars around your real car. So there are such projects, we know of them. We don't use it ourselves at Eatron. But I know that there are such projects going ahead, but it is very ambitious. It's a quite crazy idea, but if it works, it will be very impressive, yes. Okay,
so yeah, I think Emerson, so that's the answer. Another question from Bruno Umut. He's asking you, in your opinion, when autonomous cars could be on sale in countries such as Brazil, India, and similars? I mean, due to the hard traffic, so the complication of the hard traffic in these countries.
Okay, well, I assume level 4 autonomy, right? This is the exciting one. That means you can have the car driverless, in certain areas. So level 4 autonomy for India, Brazil, I would also include China, where traffic is much more fun and exciting. At least, honestly, at least 15, 20 years. It is much more difficult to this kind of very crowded and people taking liberty to do their own, rules on the road. I think it's very difficult to have level 4. I mean, you can, of course, import cars, right? You can have a German car and drive in this traffic. You can activate it, maybe hack the software, but it will not work properly. Yeah. And this is also, we see sometimes in Istanbul, even on the highway, you can have people selling water. Suddenly on the, three-lane highway, traffic is stuck, and then there are people walking around. So it's not a highway anymore, it's like a city condition in the highway, right? And of course, our software is not detected developed to detect salespeople on the highway. So such things can happen in this kind of developing countries, and I expect at least 15, 20 years before level 4 autonomy could be applied in a very busy traffic in India, for example.
Perfect. Let me use the question from Bruno, and so you said 15 to 20 years in the condition of developing countries. How about countries? How about like for instance, Europe as a region, or probably even easier, like for the driving condition of the US? When, in your opinion, it will be these cars available on the regular traffic, not in closed condition, not airports, not schools, but let's say in the real drive condition, highway, streets in developed countries.
No, I understand. So again, you are saying level 4, right?
Level 4. Let's say level 4. Level 4.
Yeah, level 4 autonomy. So in US, and there are a lot of trials in US, in San Francisco and things like that. So I expect that autonomous taxi services, driverless taxis, after in the 4 or 5 years in certain limited regions. So by 2025, for example, the company like Waymo, I think they're advancing quite a lot. So I expect that in certain areas, in big cities, they will have this autonomous taxi services in 4 to 5 years. They're already testing a lot. But then having it in the wider sense, I think at least 10 years, also in developed countries, having level 4 in a quite commonly used areas. And because the problem again, the level 4 today, you can have some systems working very well on a nice day. Like today, we were very lucky. Also in England, it was very nice day and sunny and everything. Yes, then it works. But as soon as you get, bad weather, rain, and in winter, some fogs and snow, again, it becomes very, very difficult to have a safe system. So the other catch could be, you can have some software features, level 4 features that you can activate during summer in a nice day, but then you have to turn it off when it becomes, a bit bad weather and under difficult conditions. That could happen maybe after 5-6 years, but in reality, I expect at least 10 years in developed countries, apart from the taxis, driverless taxi, and in developing countries, 15 years to have safe application.
So basically, from what you are saying, we are like, I mean Brazil as Latin America, we are like 10 years behind due to the different
roughly 5
conditions.
years, let's say 5 years. It's more for testing validation. I mean, let's take it that way. Our use case in the developing countries are much more challenging than in a nice traffic environment like in Japan, or I don't know, in Norway or this kind of countries. So it takes more.
You mentioned about the depending on the weather conditions, so turn it on, turn it off. Do you, in the customer perspective, do you think is it acceptable? Let's say, okay, now the weather is fine, so I can use. Then when the weather is not fine, I cannot use. In the basic customer point of view, they are not expert on cars, either on machine learning, artificial intelligence. For them, okay, I bought this system, I want to use every day and everywhere. Do you think is in the customer point of view acceptable to have this condition of selecting on and off?
Well, for some customers, yes. But then there is a very, there are a lot of different type of customers. There is the adventurous ones, there are the techie ones, but then there are the less risky ones and the retired people. So in general, I would say there are two main factors. One is the type of customer you are, and maybe 10-20% they wouldn't mind, fine, because they like this kind of technology and action and adventure, fine.
The early adopters, right?
Yeah, early adopters, and we see them, I think the buyers, I think that is the typical example. But the other factor would be how much money you pay for this. So if you pay a lot of money, right, Anders, and then people say, but then you can only use it when it's sunny, and you will get upset. You say, come on, I paid so much money, and I can only use this on a nice day. But if it isn't that expensive, and of course this expensive, a lot of money, less money is very relative, depending on where you are in the world, right? But still, if it isn't that expensive, then you might tolerate this. But if you sell an expensive feature and you can only use it on a nice day on during summertime, so I think a lot of people will not like this. But on top of that, even then, it is risky. If the software isn't fully validated, if the safety case is not fully developed, after a few accidents, there will be a backlash, and there might be a lot of negative PR. So I still think, even I propose that there could be an option of turning on and off. A lot of OEMs probably wouldn't go for this, because this could be a lot of negative PR, right? If suddenly some people, having accidents and getting injured and killed, this is not nice.
I think especially for this mass selling companies, right?
Yes.
Tesla is very specific. You're already paying a lot of money for a Tesla, right?
Yes.
Okay. There's another question from Jefferson. He's mentioned if you are aware if there are happening some partnerships between university, R&D centers to train the new engineer, the new professional for them to be ready to implement these new technologies on cars, on vehicles?
Again, that's, I think, a very, very good question. It has been a big discussion. I mean, since I started in automotive professionally, there is always question is what kind of engineers are coming out of university and what industry needs, right? You also know it. You come across this discussion.
Yeah, exactly.
And when we talk to professors, of course, their story is they have to teach them all this, you know, the fundamentals, the physics, the maths, and that, and all. So they have this 200 years of training engineers. Of course, industry needs people that they can immediately start on Monday, and then on Tuesday start writing machine learning, Wednesday go to the laboratory, Thursday embedded coding, and Friday, you know, testing in the car. And there's a big mismatch, and this is an open point. I think there is a lot of improvement also thanks to this technology, you know, this internet, online training and courses that's helping, but there is still mismatch between what we need in the industry and what is coming or what we are taught in the university. And there's a lot around about some of the processes, like the software development process. Of course, we don't teach the process in the university, right? We have to teach this in the industry. Like ISO 2662, this safety process, you learn this in the industry. A lot of tricks around how to integrate software with hardware, you learn in the industry. So some of those things, unfortunately, still cannot be taught in the university. And the reason usually I get from professors, they tell me, Umut, there's so many subjects and not enough time, so we cannot teach all that in 4 years. So that's usually the biggest problem.
Okay, yeah, I understood. I think we face similar problems in Brazil, but of course, this should be solved in any ways, right? Probably not, if they cannot be taught during the bachelor degree or the Master of Science, so probably some specific courses that an engineer, a technician can decide. So I want to go for machine learning, I want to go to this specific subject within the broad team of machine learning, right? And through some specific courses provided by recognized university with a very good level of professors, right? Okay, there is another question from Bruno mentioned about how long will be necessary for us to achieve level 5 on the road, so the top level. So you said that 15 to 20 years for developing level 4. How about level 5?
I mean, this is becoming science fiction, right? This is what I love. So it's good. So official definition of level 5 is autonomy anywhere, anytime, under any condition, right? Really, level 5 means it can drive anywhere, under any condition and any region. So if you ask me as an engineer, Umut, I say this is never possible. Because, you know, driving in the forest, driving on the snow, driving for software to learn. But if I have to push, then, yeah, let's say 25 years, maybe 30 years, this level 5 thing. To really having like an expert driver coming out of AI machine learning. Yeah, 25. Because even sometimes I think about myself, or for you, Anderson, there are conditions that we cannot drive as human. Right? Like heavy fog. You don't see the lane, so you cannot see ahead of the 5 meter. So it's very difficult to achieve, I think, a level 5. So I believe the real limit is level 4. So this is what I believe. But if you want me to push, then 25 years. Yeah.
Okay, clear. There is another question from Takahira-san. It's our friend from the association. So first, he's congratulating you for your presentation. And then his question goes to how to speed up integration between computing engineering and automotive engineering.
Okay,
how to speed up this integration?
No, I understand, because this is a real challenge we face, and this is an active area of discussion. For example, even with our CTO, John, probably he's watching, we discuss about the next 5-10 engineers that we need to hire, and there's a lot of discussion, how many software computer scientists we need and how many electronics and mechatronics people we need. And the discussion is we need a lot more computer scientists than maybe we originally planned. So the best way to integrate, of course, this integration happens when they work together. So we need to bring more computer scientists or the software people into automotive engineering. But in order to do that, I think we need to create the right environment. But we should not only bring them into the research labs, because research is only one part of automotive, what we do. But they need to really go to also the vehicle testing, the battery testing, the ADAS testing, to really understand the full automotive software development, so that they can help us in every stage of the developing these intelligent products. At the moment, we have them a lot in the beginning of the process, so a lot around the advanced concept, the proof of concept, the demo, doing the initial part, but then usually we cannot bring them the complete validation and verification process. So that needs to improve. I think we need to bring them more towards the final stage of automotive product.
Yeah, and I forgot to mention, Ricardo, the Takahira mentioned one thing related to this discussion. He mentioned, for instance, from one side, one wants everything open source, and other first sign an NDA and work on intellectual property protection. So it's a kind of opposite directions. So how to handle this open source versus the protection of intellectual property?
Okay. I mean, immediately I don't have a real answer to that, right? But I'm from automotive side. So we like open source when we use it, but we don't want to open our IP, because IP for us is, at the end we need to create value, we need to create some good software solutions. But of course, in order to make some sustainable business out of this, we need to protect our IP and expertise as well, know-how. And currently, I cannot see how this could be really solved in the current business models we are running. And one thing they do, and some companies, and again we can mention it, I think Tesla opened their patents and all that. So certain patents could be opened, but the real IP is what is in their software. And nobody will really open their BMS software, or ADAS software, or ACC, or perception software, or emerging software. So I think that part at the moment needs to be kept confidential, to create sustainable business model. So I don't have a solution to open everything up, unfortunately.
So you mean that if you do it, probably all your studies, you cannot make it profitable. You cannot make it feasible, right? If you
anybody can copy paste it, right, Anderson?
Yeah.
Then so you don't need my solution anymore.
Yeah, exactly. So, and you spend a lot of years, a lot of money, and yes, I just copied. Okay.
Unfortunately, this is the tough side of business that we have to also bring into discussion. Because without making a sustainable business model, we cannot bring our development forward, right? So, and by the way, I'm also enjoying my Red Bull here. So maybe some people think it's a nice English beer, but it's a Red Bull to keep me awake.
I was wondering. The only reason I didn't ask is because you're not driving. You are sitting at your home now, right?
Yes, definitely.
Okay. One question here. In your opinion, what are your thoughts related to the implementation of AI to develop higher levels of vehicle automation, as you mentioned, L2 plus or L3 or even L4? Do you consider R&D partnerships between foreigner and Brazilian companies feasible? So trying to join forces between, of course, you are probably guys a little bit ahead of us, but you have as well very good engineers in the country. So trying to share the knowledge and try to probably try to make it feasible in an early stage, joining forces.
No, in general, yes. I mean, I've been in automotive, 20 years, and I work with a lot of great Brazilian engineers. I got friends, and I know that Brazil is very strong in automotive. It's a big market and all that. Even 5 years ago, I did a big project with Brazil in my previous company. So I know Brazil is a very, very big automotive market. It also has, I think, very, very good engineers, and also in England, there are a lot of good engineers from Brazil in automotive. So cooperation is definitely possible, because as number one is it's a big automotive market. So that means it's important for automotive. And of course, it's a very, very dynamic traffic environment as well. A lot of big cities. So it has a lot of edge cases that you want to test your autonomous functionality. So I see this is definitely possible. But when I was thinking, I think Brazil is also, there is the mainstream automotive, right? But there is also mining. There is also tractor, agricultural automation. So I see that Brazil also has, I think, a very strong potential in this non-automotive, out of automotive, the traditional automotive automation area. So like the mining trucks, it's a big area for automation. All the tractors doing automated agriculture. So all this, I think, is Brazil could really become one of the leading nations, in my opinion, because you have the resources, you have the business model already, you have a lot of resources, so you are already doing all this. And with your engineering talent, you can really start implementing all this AI machine learning to automate this non-passenger car part of the automotive, because they're also vehicle and needs to be automated there as well. But yes, I think there is a lot of potential for cooperation.
And I think an important point here is because, of course, automotive, it's a scale industry, right? For instance, if you have the condition to develop here with the local engineers, so to export either the technology or either the car with the technology, it's fundamental, right, to make it feasible. So scale is everything in our industry. So, right?
Yes. I think usual problem there, Anderson, is the funding. I think the skills of the market is very attractive, but how do you find funding, to do this work is more difficult in developing countries. There is a lot of money in Silicon Valley and maybe certain areas in Europe, maybe in Japan for this kind of funding. But when you go to developing countries, unfortunately, the funding is the limitation, not the people, not the infrastructure.
Yeah, but if the knowledge are leveling, so are at the same level, eventually the local engineers are cheaper than, for instance, American ones, right?
Yes.
Just one point. There is a question from our common friend, Max Mauro, that he was the guy
Max.
that introduced me to you. So his question is, how do you integrate the HD maps from L2 Plus and about the L2++ definition?
Well, HD maps, we think is very, very important for localization. And localization, as you said, becomes necessary for L2++, but maybe to keep it simple, let's call it level 3. So for level 2 safety case, because now I think we all agree that safety is so critical, and level 3 means if there's a special case, because in level 3, driver doesn't need to take control of the car immediately. So you need to give some time to driver to recover from whatever it's doing, maybe reading a book, right? But when you hear the signal, maybe you have 30 seconds, 1 minute to take control. But even if you cannot take control in level 3, the safety case is that you have to take this car to a safe position. So usually maybe go to the emergency lane, right, and then park there. So in order to do that properly, the general understanding in the industry at the moment for ADAS is you need HD maps, because you need to know very well where the road is. So for that, it might be required. Or if you want to do inner city driving, because highway is relatively less difficult, but if you are really want to do this automated driving within the city where there are a lot of people, pedestrians, bicycles, and all that, and there again you need to have this very, very precise localization and the higher safety concept, then you need HD maps as well. So for higher levels of autonomy, at the moment we need HD maps.
Okay, the more you go up, the more you need the HD
and it
map.
becomes more expensive, and yeah, so all that.
And you have more computing power.
Yes, more sensors, more electronics, and that's the reason why I say with level 4, although you can have these the taxis, because a taxi can be very expensive and pay itself in 4 or 5 years, it's very difficult to sell a level 4 to people like us, because you cannot make it, as cheap as like $20,000, $30,000, even $50,000 wouldn't be feasible for level 4. It may be at least, I don't know, $200,000, $250,000 car if you go to level 4 today.
For sure, not for the mainstream customer.
No, definitely not.
With this level 50,000 or more. Another question here, Umut. During your presentation, you mentioned that safety is very important for AI, especially talking about automotive sector. But how do you ensure the safety of your AI software from ADAS? How to ensure it?
So this is a still open topic. So a lot of different companies and research groups are working on this. The methodology we are using when we develop an AI software, we really develop another non-AI software next to it, right? We call it a safety layer. And all the inputs and outputs going into that AI software is being monitored and controlled by this other non-AI software. And we define a safe envelope, an operating region. And if the other software detects or observes that AI software wants to do something that is not safe for that operation area, then we don't send the signal of the AI to rest of the car software. So we really stop it. So you can think that AI is this very powerful, maybe young Superman, but there is another older Superman next to it and controlling, very carefully monitoring this younger one. And if this younger one wants to do something unsafe, it just stops it. So we have this monitoring safety software checking all the input and outputs of AI software. And we do that for each AI application to make sure that it's safe. And maybe this is not the best solution, but at least we know it is a safe solution. Yeah.
This condition builds up on costs, right? Because you need to have a checking.
Yes, cost and complexity, and of course sometimes you lose performance. But we all know it.
Right? Okay. Yeah, because safety means you lose speed, right?
In general, it's not just speed, but I mean, think about it. Safe driving means what? If there's a sharp corner, if you are driving safely, then maybe you reduce speed, right? That means you lose 1-2 minutes.
Correct.
And a more crazy guy who doesn't care can take that sharp corner much faster, and maybe 90% of the time nothing happens, but 10% of the time he will end up in the hospital. You will go to where you are going, but maybe 5 minutes longer. So safer you are, you always lose some performance, but you improve your safety. So that's kind of the catch. Everything like in life, I mean, when you go more faster, more crazy, okay, maybe sometimes you achieve something great, but then you always tell this, right? You make this joke, don't try this at home, because you can do it, you're the great guy, but if usual people try it, it's not a good idea. So yeah, safe means you lose some performance, unfortunately, and it becomes a complex system, slightly more expensive system, yes.
Yeah, because in case of us human, right, you have different of skills of driving or these kind of things. In the case of software, you need to set up the standard, and this standard will analyze the several driving conditions and take the decisions. Of developed during all this machine learning process and all the engineering process, right? Another question from Takahira. Takahira is very inspired today to make questions to you.
Thank you.
He wants to know the connection between autonomous vehicle AV and the concept developed in Japan in 2014, the Society 5.0. What are when and where they connect these two?
Can you help me, Anderson, with Society 5.0? Is this fully automated cities, and what is this concept in Japan?
Yeah, the concept basically, I mean, to be short, basically is with all this digital transformation we are having globally, right? The IoT, AV, right? Machine learning, AI, all how to have a contribution to the society. So the positive social effect of digital transformation. In a few words, it's something like that.
No. Thank you. No, I understand now. And well, I think there's one-to-one relationship, right? Because part of this Society 5.0 sounds like the expansion of this Industry 4.0 in Europe to complete society even higher level. So the autonomous driving, these AV cars, pods, whatever you call them, will be part of this Society 5.0. And it will bring immense benefits to society. I mean, we all know that, right? For old people, for injured people, and also for our comfort, safety. So there's so many things you can achieve. So I fully agree that that's completely part of it. But there are also negative things, maybe not really relevant for engineers, but one is our privacy, right? Okay. At least this whole big Society 5.0 knows everything you are doing, including the car, wherever you are going, at what time. And of course, today it's not my expertise, but cybersecurity, with all this whole connectivity, digital transformation, I think cybersecurity will be a bigger and bigger concern for all of us, because people can steal our digital identity. They can take control of the car, this full autonomous pods. They can, capture you, take you somewhere. So there are a lot of benefits, but again, as a sci-fi fan as well, I'm scared about Big Brother watching us all the time, more and more. So hopefully we can find the right balance between all this moving to the Society 5.0, full autonomy, all this machine learning AI. I'm not still worried about this Android human-like AI or this generalized AI. I'm not worried about this super intelligence, because I think that's real sci-fi. There is no real science behind it. But I'm really worried about cybersecurity, privacy, and then freedom within the society as individuals. Yeah. Hear you, Anderson. Are you muted?
I'm sorry. So basically, what you said about this cybersecurity, in some ways, could be included on the safety, right, of the customer, of the safety of the user, right?
It is related. It is related, but it has different certification processes. We are also looking into it, because what we see both on BMS and ADAS, of course, we have this concept of over-the-air update. So actually, you can update the software of this electronic units when they are in the field, after you buy it. Again, Tesla does this all the time, which is a very good feature. But that means you have to make sure that once all these electronic units are connected to the internet, to the cloud, cybersecurity becomes a very critical topic. But when you look at closely, safety is more like a passive safety, because when we are designing the system, we make sure that it's safe. Right. Cybersecurity is external, because some people attack.
Okay.
So there is slightly
a kind of different concept.
They're connected, but in the deep down, there is a philosophical difference, but they are connected. Let's say it that way. Yeah.
Okay, no, but I understood now. It's a different classification, but there are a clear connection between them, right? So during your presentation, another thing that I want to enter on this subject as well, you mentioned about one of the technology you developed at Eatron related to BMS. Okay, so my question is, can you increase BEV range using AI-powered intelligent software?
Yes. That's I mean, that's a good question, because sometimes we have this kind of discussions within the industry with some experts, and so having an AI-powered BMS, of course, gives you the chance to have a better management of the battery and the battery cells, right?
Okay.
And of course, if you can manage them in a better way, then normally you can reduce the aging of the battery cells. So aging is one of the biggest problems of the battery pack. And again, we all know it even before the time of EV. Remember our small batteries that we were using when we had the Walkmans. I mean, the young people wouldn't remember, but I know that Anderson and I, we are at the same age. So we remember our Walkmans and this little
that's life. That's life. I remember.
Yeah. And you know that especially if you leave them on the hot day outside, whatever, some places, then you come back and suddenly there is no electric left in the battery, right? It's charge out, discharge. Yeah. So really this aging and not properly or abusing the battery pack is the worst thing you can do. And if you use this more intelligent AI-powered BMS, the machine learning, we can reduce the aging up to a point. And if you reduce the aging, of course, you can get the performance of the battery or the optimum performance for a longer time. So the improving the range, maybe, but definitely you can extend the useful lifetime of the battery pack. So I think, yeah. So the range is, I'm more cautious with the range, but definitely you can extend the lifetime. So you can use that battery pack much longer using AI-powered BMS.
Yeah, but I believe that both results can support increasing the competitiveness of EV cars, right? Of course, range is more appealing to the customer, but of course, you can have a battery that instead of the life of the battery to be from 5 to 10 or 10 to 12, of course, this is appreciated as well, right?
Yes.
Concerning your AI software, so considering the training, you are training a client on your AI software. How much do you rely on simulation versus real life testing?
Yes.
It's 50-50 or what's the...
No, I think that's a very hot topic as well. And what we see, because the training this AI algorithms, these neural networks, actually very time consuming, right? And one way of doing it is using a lot of data, real data. But unfortunately, very few companies have access to a large data set in automotive. And then usually they are some of the OEMs or very, very well funded, these big startups. But even in that case, it is very time consuming and very expensive to get a lot of real life data for every special case, every edge case. So the simulation is very, very important to give you a lot of data in a short time without spending a lot of budget or having a huge fleet on the roads. Also creating some dangerous possibilities. We know that some of these startups had some accidents. So we rely on simulation a lot. We believe that in the beginning, a lot of the initial training of the AI machine learning needs to be done in the simulation environment. But of course, you need to have the right simulation environment with the realistic graphical interface, so you can create this very realistic virtual domain. But then you need to have all the physics inside because you want to have the vehicle model and all that. But plus, then you want to be able to create all these scenarios within the simulation. So one thing we are trying, yes, we use simulation a lot, maybe 80%. trying to push it to 90% simulation, and then do the rest 10 to 20% in real life. But also we try to create some AI. I think I mentioned that briefly, a master AI in the simulation that will train and validate the ACC, ADAS AI or other AI that we like to create as a product. So we like to have AI training other AIs, which we think will give us a real advantage to speed up this development of safe AI for automotive.
So roughly your targets is around 90 to 90, 10.
Yes, but at the moment we are more like 80 to 20. Yeah, at the moment we are 80 to 20, but trying to get 90% to 10%. Yeah.
Okay, understood. Okay, so we are almost running out of time here, but I have one question that is very linked to the current situation. All the globe are struggling now, right? Which is the COVID-19. So then my question, so final question to you is, what is the impact of this pandemic, right? The COVID-19 in the introduction and implementation of AI, of course, let's say machine learning, it's a more appropriate word, on autonomous vehicle globally. Is it going to speed up or slow down, and why? Your final question too.
Yes. No. This is a good question. I mean, I will separate short-term and mid-term, long-term effects. Okay. In the short term, what I will see that it will actually put a lot of small startups and even some big ones into difficulty. I will see that maybe at least half of this autonomous driving developing startups, even some bigger ones, might go out of business because of funding is drying in the short term. So this will be like a selection process, evolutionary. So a lot of weak ones who cannot manage these difficult times, the next 6 to 12 months, they will get out of business. But then, so this is the short. So short term is bad. So we will have, some difficulties, shutting down, cash problems, or cash decisions. Even if you are a big company, you have to decide where to use your cash in this difficult time, right? And then you might think, and if they have some people like me who says, yeah, but this will take 10 years. And a lot of the very senior guys says, come on, I will not be here in 10 years. So, I need to secure the next 5 years.
I already heard about that.
So the short duration, this is negative. So there will be less startups, less technology companies doing AV. But after that, the ones who survive will be much stronger. And I believe there will be more money for that. The pool will be maybe similar, but there will be less people, the companies or teams trying to get money from this pool. So overall, I think this will be good. Overall, in the midterm, this will accelerate. There will be stronger companies, stronger products, and the whole COVID situation actually accelerated this society 5.0, the digitalization of the whole society, the whole world. So in the short term, it's difficult for all of us, but in the midterm, I think this will be much better for everyone, also for autonomous driving. So the ones who survive this crisis will create better autonomous driving solutions in a shorter time. This is my view.
Okay, thank you very much. I think let's pray for several companies to survive, because as you mentioned, right, at the end, funding is all about, how can I say, effectiveness, right? So if what you invest can bring benefit to the company, to the society 5.0, of course, this funding will for sure come up. But current situation, it's a survival mode, right? So you don't need to care about tomorrow if you will die today, right?
Unfortunately, yes.
Yeah. This is life. Okay. So now, as a final moment with you, Umut, I would like to give you a couple of minutes to let a brief message. So about now I made a specific question about AI, but now it's a more philosophical, let's say a more generic question. Brief message about to the world in your point of view, both in professional, personal life. So what are your thoughts on that?
Well, I mean, I have a lot of thoughts on that, but let me try to summarize. And this is very, very personal view. But one thing I see that this somehow actually, although physically this crisis created distance between us, but in terms of communication and emotional, I believe that this crisis brought us closer. And even what we are doing today is an example. I think we get more connected, and we also value our relationship, our friends, our supporters, our colleagues. I think we value them, I think, much more now during this crisis, because we understand that it's very important to have a good relationship, a strong society, a good network supporting you at work as well as in your local private life. So I'm more positive, and I think if I bring it into the engineers, because I assume we are a lot of engineers and scientists in this call, I believe people realize as engineers and scientists we make a great contribution to society. We were doing it before, but they realize this technology is so important to keep people alive, detect these problems, help people in quarantine. Like this autonomous technology is so important, this connectivity is so important. So really, I believe the lessons learned from this crisis will be positive for the whole world. And I hope that we understand, maybe we speak different languages, maybe we are different countries, different nations, I don't know, different NATO, different that. But actually, and I put my sci-fi thing, if you go to the bigger picture, we are very small even compared to our star, sun. We are really, really small. But then if you go to the Milky Way, we are nothing. And if you go to the whole galaxy, really, we are like a little dot. And then we are, I don't know, what is this electrons on this little dot, in this world. So we should help each other, and we should care more about the people, the society around us. Nobody can survive in such crisis alone. I think that's what we learn.
Wow. Thank you very much, Umut.
Thank you.
I think, we are too optimists. I have a very similar opinion that what the difficulties make us stronger. We are struggling now, right? And with the quarantine, lockdown in some countries. And but for sure, I have the same view that the situation in the near future will be better, and we should learn from this pandemic, and so I'm totally aligned with your comments. So we are basically two optimists.
Yes, very good, very good.
All right, so I would like to thank our local and international audience. I really appreciate all the questions raised. And my final appreciation is to you, Umut, for your availability to be with us up to late at night your time. And answer all the questions. So it's a very, very candid answers, and we really, our audience really appreciate it. Thank you very much. And just one piece of information for you. So we have our audience here, and it was a very hard decision for us, AEA, because it was a very unique situation due to the pandemic. From yesterday to today, the local government decides that today is holiday in São Paulo city.
Oh,
so of course this impacts a little bit our numbers, but I didn't want to tell you before. I'm telling you now just at the end. But for the people that attended us today, they created a bridge from yesterday to next Monday or even Tuesday in order to avoid people moving around and try to reduce the COVID curve, right?
Okay.
To protect our health system. Okay, so this is just a piece of information. But anyways, thank you very, very much. Now I will just finalize. Please hold on a bit.
Okay.
I will finalize the transmission. Thank you. With some final comments in Portuguese.
Ok.
Eu começo com um aviso, né? Começo para terminar com um aviso para os que chegaram depois do início, né? E mesmo os que, né, não tiveram a chance de participar hoje, eventualmente até pela questão do feriado, né? Que foi decidido de última hora, né? Mas o vídeo ele ficará gravado no nosso canal. Então, né? Basta só se inscrever. Podem assisti-lo aí na íntegra e aproveitem, né? E já deixem aí o seu like, a gente agradece. E no intuito de melhorar melhor atender vocês, nosso público, peço que coloquem suas sugestões de temas, de tópicos para as próximas lives nos comentários desse vídeo. Eu vou estar checando isso de maneira regular né, para estar negociando os próximos assuntos e próximos convidados. Mais um ponto, conforme eu comentei no início da transmissão, a nossa próxima live AEA Digital, ela vai ser ainda nessa sexta-feira, então aí dentro desse... Sexta-feira, né, ficou como facultativo, então, né, não exatamente é feriado. Nessa sexta-feira, dia 22, às 4 da tarde, às 16 horas, com o tema Conectividade com a introdução do 5G, onde debateremos esse assunto, né, bastante relevante, sendo bastante discutido atualmente, com o senhor Hélio Akira Oyama, que é o diretor de gerenciamento de produto da Qualcomm. Para você que se interessa por esse assunto 5G, conectividade para o setor, né, automotivo, compartilhe um convite com seus colegas, participem, né? Peço que participem das lives, desta live, e nos ajudem a debater com o nosso convidado através aí das suas perguntas e também comentários. Pessoal, além do nosso canal do YouTube, como eu sempre comento, né? Fiquem ligados nas outras mídias da EA, onde postamos regularmente a nossa programação, né? Então, stay tuned. Mas antes de encerrar a live de hoje, não poderia deixar de agradecer novamente a vocês, né, que por vocês estamos aqui, né, a audiência de vocês no YouTube. Obrigado e aguardo vocês nesta sexta-feira, ainda dia 22, às 16 horas, e conto com a participação de todos vocês, e até lá. Obrigado.